Chapter 440, Wash Process Parameters. We try to characterize wash parameters depending on the impurities of the input material. So you see the removal of impurities depending on the process parameters. As in your laundry machine, we have different wash programs, a dry process, a one-step wash program, 2 steps, 3 steps, and then you can intervene on parameters such as the water temperature, the chemicals, or the reaction time. The first parameters, the number of wash steps, are mainly CapEx and partly OpEx investments. So CapEx, why? Because if you need 3 wash steps, you need more machinery in comparison to a one-step wash line that can be shorter and less expensive. The OpEx, the operation costs depend on the parameters that you use, water, chemicals, and reaction time. So we want to characterize the kind of behavior of input material depending on the impurities that you find in the input materials: added impurities, adhesive impurities, cohesive and intrusive and destructive impurities. Let's start with materials that are typically added to products such as the trays. You have the films or the bottles, you have the caps and the rings and the labels. So all these accessories can be very simply removed in a dry process. You don't need a wash process. This is state of the art. It is simple to do. It becomes more difficult if you have really adhesive materials such as sand from the beach or mud, as we see on the left side on the bottom picture from an inundation in Italy. So you have to wash it out. But this is relatively simple. You need a simple wash step to do so, and you come back to really good output quality that is near to the original material that you had. So cohesive material could be any kind of shells or algae or other biological material that is really sticking on the bottles, on the plastic waste. So you can imagine as paper labels that stick to the bottle by glue, this kind of shells that stick to these bottles or to this net, the algae that are inside, these are really material that are more difficult to remove. So there we are. We have the cohesive material that will not obtain the same quality as we have described for the adhesive materials, but we have a net improvement as well, but it will take more time. It will take 2 or 3 wash steps, and we would need a use of water temperature, chemical, and perhaps longer reaction time. Last but not least is material that had suffered from degradation, such as thermo-oxidative degradation, meaning the heat on the beach combined with solar radiation or hydrolytic degradation, meaning the travel in the water that also helps to degrade the plastic material. So here you see material that unfortunately will not come back to the initial um, uh, product quality. You may remove embedded impurities, but not all of them. And this kind of partly destructed or degraded material is really difficult to recycle later on as virgin material for a new product. So let's say some little points about the necessary energy that you need, water that you need, and chemical agents. So in the dry process, you have some energy, but if you go to a wash step, you would need more um, mechanical energy, perhaps twice as much as in the dry process, and you would need some water as well. If you double the number of wash steps, you come to more machinery and even more water use. And there's no surprise if you have 3 wash steps, you would have even more energy that you would need, mechanical energy, and more water that is used and normally recirculated after water treatment. If you use hot water, you need more thermal energy. So let's say heating up the water is an additional effort. Another additional effort would be the chemicals that you add. You see a little yellow arrow there. And if you have longer travel time of the input material in your wash line, you need more chemicals, more energy, and more water.